Bismillahirrahmanirrahim. Some of the students asked to repeat the concept of code division, repeat the concept of carrier sense multiple access with collision avoidance. In other words, they asked to provide a step-by-step overview of the entire process. So let's discuss it on the with the help of the whiteboard. So as we know that the carrier sense multiple access collision avoidance basically consists of two processes. The first process is the carrier sensing and the second process is the collision avoidance. So please keep in mind that carrier sensing is a continuous process. It means that whenever a node wants to transmit its information, it will keep on sensing the medium again and again and again. And this sensing will happen continuously. So this is one of the most important concept in the carrier sense multiple access. Because each time a node receives some information to transmit, rather than transmitting it directly over the medium, it will first and most importantly, it will sense the medium. Then if the medium is free, it will perform its remaining tasks. Now what is collision avoidance? Collision avoidance are actually some added measures described in the protocol to avoid collision between different nodes, or in order to avoid collision of information when multiple nodes are trying to share the air interface that is also a shared medium. Now, as discussed in our previous lecture or our previous part, basically whenever a node receives some information or whenever a node has some information to transmit over the medium, what will happen? It will sense the medium. So hence start the carrier sensing. Now, this sensing of the medium will happen for a particular amount of time, and this amount of time is commonly referred to as distributed interframe spacing or diffs. Now after diffs, if the medium is still free, what will happen? The node will transmit its information over the medium. Now this is the case of a single node when the entire medium is free for communication. Okay, so let's change the color so that we can discuss other points as well. Now, let's suppose let's consider the same node, and the same node gets some information that he or she wants to transmit over the channel. But at that particular point, what happens? The medium is busy. In other words, another node or another station is already transmitting information over the medium. So when this particular node senses the channel, obviously this channel will be busy and this particular node will defer the transmission of information. Now, the process of carrier sensing as discussed is continuous, and this node or this station will keep on sensing the medium until it gets free. Now, when the medium gets free at this particular point, what will happen? It will wait for the diffs amount of time. So it will wait for the DIFS amount of time, and after waiting for the diffs amount of time, it cannot transmit the information directly. It will wait for some additional period of time that will be defined by the contention window. Contention window actually defines the or translates the Backoff timer, which is added with the diffs and hence concludes the total amount of time that the node has to wait in order to transmit his or her information after the medium gets free. So this is the case when a node wants to transmit information and the medium is busy. So when the medium gets free, a node has to wait first for diffs amount of time, and then it has to wait for the time that is defined by the contention window, and this is commonly referred to as the backoff time. Now this backoff time is a random time, and it is selected randomly depending on the values picked from this contention window. So the overall weightage time will be diffs plus the back of time in case when the medium is busy and this particular node wanted to transmit its information. So this is the second case. Now let's clear the screen. Okay, now let's consider another scenario. Sorry. Let's consider another scenario in which multiple nodes are involved and multiple nodes wants to transmit their information over the medium. So we started our example with a single node in which we stated that each node has to wait for diffs amount of time before transmitting his or her information, provided that the medium is free. Then we extended our example to the case of two stations when a node wanted to transmit its information, but the medium was busy. So what happened? The node kept on sensing the medium or the channel, and when the channel got free, it waited for the diffs amount of time plus the back of time before transmitting information over the channel. And after this amount of time, if the channel is free, so he or she can access the channel. Now, what happens if another node transmits information during the back of time? So now we will consider this particular scenario. So let's suppose we have a station that wants to communicate information over the medium. But when it senses the medium will be busy as another station is transmitting information over the medium. So what will happen? This particular station will keep on sensing the medium, and it will sense the medium until, and it will keep on sensing the medium. And when at this particular point, and let me extend this to make it clear. And when at this particular point, it finds that the medium is free. So what will happen? It will start its diffs timer plus the backoff timer. Now, let's suppose during the backoff time, what happens? Let's suppose this particular node, for example, for the sake of example, we are making it very much simpler. Let's suppose during the backoff time, this particular node starts transmitting information over the channel. So obviously the channel will be busy. So what will happen? This station, that is station 1, let's call it station 1, call it station 2, and call it station 3. So station 1 will stop its backoff timer at the point when station 3 starts transmitting information over the medium. It will stop its backoff timer and will keep on sensing the channel. Now when the channel gets free again, what happens? It will again start its diffs timer And after the diffs timer, it will again start its backoff timer. But instead of selecting a random backoff timer again from the contention window, it will initiate its backoff timer from the point that was left before. Now, after the backoff timer, if the medium is free, then he or she can transmit information over the medium. So, what is the advantage of this particular scheme? Now, the advantage is that let's suppose if station A started its backoff timer at this point, and during the during the process of the backoff time, the medium got busy. So obviously, it has not to wait. And during the backoff timer, the medium got busy again. Okay, so it will stop its backoff timer. Now there are two options. The first option is to initiate your backoff timer again from the beginning after the medium gets free and waiting for this amount of time. And another option is to initiate the backoff timer from the point where it was left. Now, the prior has some disadvantages. The disadvantage is that the backoff timer is selected randomly, and by random selection, a node obviously has to wait for a larger amount of time, or another node might get access to the channel more quickly than this particular node because the timer is selected randomly. Now, this problem is overcome by what we just explained a few minutes ago, that instead of, let's draw the entire thing again to make it clear. So let's suppose if this is diffs amount, the node is waiting for diffs amount of time, and after diffs amount of time, the node has started its backoff timer. Now at this particular point, let's suppose the medium gets busy, so the node will stop its backoff timer. Okay, at this particular point, the backoff timer is stopped. Now, when the medium gets free, what will happen? Rather than selecting a random backoff timer again, the node will select its backoff timer from this particular point. So this will be the total duration of the backoff time that the node has to wait now after waiting for this amount of time. So obviously, this gives an advantage to station 1 because it has to wait for a lesser amount of time as compared to the other stations that have just joined the race. So I hope it's clear.